Hey robot makers, hope you're having a good day so far and you're not being blown away by the very strong winds at the moment. So, are weather sensors any good? What can you do with the data that you get from them? Do you want to know how to send that raw data to something like Grafana so you can create some really interesting charts and amazing dashboards? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to our keynote and talk about weather sensors today. So I've been looking at the Pimoroni Weatherhat and using that with the weather sensors that you get with it. So there's we can have a look at what they look like, and I've got a little video clip for you as well as it in action. So yes, today's session goals, we're going to review the Weatherhat and Grafana setup, how we get data from something like the Weatherhat and put it into Grafana. And there's quite a few steps along the way, but they're all quite simple and it's all free open source software. So we're going to have a look at what's inside the box that you get with the Weatherhat, mounting the sensors. I made a bit of a hash of this and I'll show you that shortly. We'll have a look at the Python library, which is really cool, and we'll look at how we can get that data using MQTT, which is a broker for sending and receiving messages. We'll look at Node-RED, how we can receive that data from MQTT and push it into a time slice database, InfluxDB, a time series database, and then looking at that data with Grafana. So it's quite a packed show today. Let's get into this. So yes, I received a Pimoroni Weatherhat and they were very kind to send this to me, so I'll have to put the little flag on the show that says that this is a paid promotion one today, although it's not specifically just about that. So yes, this has a little 1.54 inch LCD screen, colour screen, has 4 buttons on there as well, so you can program the buttons to do various different things in conjunction with the screen. It has a bunch of onboard sensors to measure temperature, humidity, pressure, light, and you can also connect up 2 other external sensors, rain and wind as well, using those 2 RJ11 connectors on the board. And it works with any Raspberry Pi apart from the very first edition one, which had less than 40 pins. So if you've got a 40 pin header, it's pretty much going to work. And in fact, the Raspberry Pi I've got it working with in the back of the room behind me, I think it's a Raspberry Pi, I say 1.2B, I think it is. It's quite an old one, but it works fine with that. So this is what's inside the box. So you get a majestic size box, as they say on the website, and here's a quick clip of me installing, well, taking stuff out of the box one-handed while trying to film with an iPhone, which is a bit of a challenge to say the least. So here we go. So yes, inside here we get a bunch of things we will construct into our weather station. So let's have a look at these one at a time. So we have the rain gauge on the bottom right, and that's a really interesting mechanism. Inside there's like a little seesaw, and there's 2 little buckets, like thimble-sized buckets on it. And when they fill up with water, they'll get heavier and heavier. And then when it reaches a certain tipping point, it empties, and then the next one will fill up, and then it'll tip back. And each one of those will make it tick 1 count. And then based on how many counts you get per minute, per hour, whatever, you can then figure out how much rain has passed through it, because you know how much is inside those little buckets. So that's the rain gauge. Then there's the wind vane, which just tells you the direction of the wind, and that doesn't use anything fancy other than, I think there is 8 different resistors in it, and depending where the vane is pointing, it will make 2 resistors kind of not short out but connect together, and then it can understand what that is. So that's how that one works. Gives us the direction of the wind. And I always get this wrong, the anemometer is the sensor for wind. And I actually had one of them for my drone. This one is like a handheld version. See if we can get this to come on. And yeah, simply when wind passes through the little sensor there, it will detect what the wind speed is. So this uses a similar kind of thing. It's just how many rotations per second do you get, and therefore you can work out how many meters per second of wind are coming through. And then we have something which is called the Jubilee clips. So Jubilee clips are these little tightenable clips, like a little metal thing. You'll see them on the video clip in a minute. And they allow you to attach the metal pole to another pole, kind of a surrogate pole, to give you a bit of extra length and strength as well when you're attaching this to a building or a structure. You also get a couple of wire ties in there. You can see the top right, and then you can see the metal masts and the mounting structure. So let's have a look at this sort of being put together. But if you want to help me out, if you like these kinds of videos and you want me to make more of them, make sure you give this video a like. drop me a comment to let me know if you've got a weather station yourself, if you've got a Grafana setup. It'd be interesting to know about your dashboard setup. And if you're not already subscribed, which most people who watch these videos aren't, subscribe. You'll get notified when I do new videos, and I tend to do a live stream video every single Sunday at 7 p.m. and I also go live. I'll do a short video during the week as well as a midweek. So this is my first attempt at putting the weather station on the side of my summer house. So you can see that I didn't do a fantastic job. I just used the 2 poles that came with the kit, and what happened was it kind of pivoted. You can see there on that bracket, it wasn't held up very straight, and that's not great because it means that the rain centre is not level, and also the wind and the wind vane are not accurate as well. So I needed to correct that. So I went out and bought a huge metal pipe to improve the situation. So you'll see that attached now using those Jubilee clips, and you can see there the weather vane in action. And it's completely straight now. I took my iPhone out, I got it onto the Measure app, and I sort of held it up and made sure that that was completely plumb and completely straight. So there you go, there's a picture of me, 0 degrees, I got it completely straight and then tightened everything up. You can also see on there the 2 wires that come down into the summer house. So I've just drilled a great big hole into the side of the summer house and pushed them through, and then filled it back in with a bit of wood filler, and then I've just tacked them to the side as well. So yeah, there was a bit of snow on the roof of the summer house while I was putting this up. I wanted to sort of get the back end of Storm Eunice and see if there was any other weather phenomena going on that I could detect. Now the thing I did, and I was really thankful that I did this before I started pushing those 2 wires through the hole in the wall, was one of them. You get two cables. One is for the rain, and one is for the wind direction and the wind speed, and they look exactly the same, the connectors. So I took a little red Sharpie, and on the rain one, red for rain, I just marked on the very end a bit of red, so that when I pushed them through the wall and they came through, I knew which connector was the rain connector and which one was the wind sensor. So that's a little tip there for you if you're doing this kind of thing. So the amazing software library, and we may or may not have the creator of this joining the show at the moment. So yes, this was really helpful for putting together my own code. I really liked how simple this was to use, and we simply just create an object like called sensor. We make it a class of Weatherhat, and then we just use some of these functions in there. We can just say update. So that update function that's just here, we can call that, and that grabs all the data into the variables within the class ready to be accessed. Variables such as the temperature, the pressure, the relative humidity, the dew point, the lux, the light levels, the wind speed and the wind direction, the rain and rain total, and so on. And there's even a few like compensated ones as well in there, which we can have a look at. So yeah, really easy to use. If I can use it, anyone can use it. So if you want to grab that, if you go to a Git and do a Git clone and then type in that address there, Pimoroni Weatherhat -Python, you can start playing with that yourself. So that's the software library. And then the piece of code that I wrote to very quickly hack together something that would send up some data to an MQTT broker, which I've got locally installed just using Docker. I think I did a show about that quite a while ago, so if you want to check that out, you can. But there is a built-in module within Python that's called, I don't know how you pronounce this, Paho, and it's their MQTT client, and you can publish and subscribe to MQTT brokers very simply. So my local one is just this IP address there, and I've just called this Weatherhat as a client ID, and then the update frequency is how frequently I want to grab this data. So I've just done 5 seconds for now. And then the sensor, this is where we actually create the sensor object. We just say sensor is of type Weatherhat, and that's that class that's been imported when we install the Pimoroni library. And that means that we can then use that later in our code. And then these 2 very small functions just enable us to connect and grab data from our MQTT broker. So this is what we do to do an MQTT broker. We just say client equals MQTT client, and then we just pass in the client ID, which is up there, Weatherhat. That just means you can see on the broker where the data's coming from. And we just do a on connect, which is that function there, and then on message, that function there. And they basically just send and receive they just subscribe to the system hash thing, and also just print out whatever message comes back. And then what we then do, we just connect to that, and that just makes that connection. So there's another block of code which does the real kind of work. So the payload, that is going to be something that's going to contain some data that we want to work with, and the topic is to do with the MQTT broker. That's how we it's kind of what channel of information that we're sending things to. So I've just created a channel there called weather. On this while true loop basically just says do this and then just keep going round. So we'll get the sensor data just using the sensor update, and I'm not sure, Phil, if I'm using that correct. If I've got a update frequency of 5, does that interval need to be 5, or should that be 60, or is 1 okay? I'm assuming they're seconds. Okay, then we sleep for the amount of time that we've defined in that update frequency. We don't want to do too many snapshots because we'll end up just filling our database server with thousands and millions of records. So you want to dial that back. To begin with, you might want to do 1 a second just to see that the data's coming in. And then what I then do is just, I've got a variable called now, which just comes from the date time function there. And it just basically just gets the current date and time. We're going to use that to put a date stamp in our payload. And then what we then do is just grab all the different sensor readings. So temperature is sensor.temperature, pressure is sensor.pressure, humidity, sensor.humidity, and so on. So they're all the different readings I get. I put them all into a big string. I'm actually creating a JSON object quite crudely there. And this is an F string. If you've not seen them before, they look a bit weird, but it's just a way that you can format strings with variables in the middle of them using the little curly braces. And then once we've constructed that, we just publish that to our MQTT broker, and then that will then just pass that on to anybody else that's connected to it. So that's it, and then we just say print sending payload to server, and whatever's in that payload will then just print out. So that's my really simple program, and that's all it takes to use this particular Weatherhat. So if you want to grab a copy of this, you can actually go to github.com/kevinmcaleer/weatherhat2mqtt. And Phil, I'll send you a copy of that as well if you want to include that in the Pimoroni examples thing. It's very, very simple to use. So the software stack, this is what I've actually done to build up a couple of different pieces of technology to get the data from the Weatherhat all the way across to Grafana, so we can actually bring it to life and see the data. So that Weatherhat's just running Python. We're going to send that data using that little script I've just shown you there on the topic weather, and that's going to go to the MQTT broker that's on my network. That's actually running in a Docker instance. I'll show you that running shortly. That then publishes that data to anybody else that's subscribed. So we're going to create a new Node-RED flow, and I'll show you that too, that subscribes to that weather topic and then sends those readings to Influx. Now we could just directly from our Raspberry Pi write directly to the Influx, but by putting these other things in the way, it means it's a lot more flexible and we can change things without having to go back and change that original script. So it really decouples things and makes things really flexible. So Node-RED will then push that to our Influx database, and don't worry, we'll talk about what that is in a minute and how that's different than a regular database. So that's going to store it ready for use in Grafana. And Grafana has a built-in like a core object for dealing with Influx databases. So yeah, that's going to help us really bring that data to life and visualize it. It's really, really cool. So that's the stack of technology. So let's have a look at some of the components. Now we have done a show on Node-RED previously, so we're not going to go with too much depth, but I will show you during the demo what that looks like. So the flow looks like this. We just have an MQTT object that gets the data from that weather topic. We then convert that into a JSON object just so we can play with it and put extra bits in there. Now the two next pieces, I probably only need the second one. This one here is a little splitter, and what that will do is mean that we can just insert into the JSON object a location, because I have lots of different temperature sensors all around the house, different buildings and so on, and they all publish to that same MQTT broker but on different topics. So there's like one in the loft, there's one in the bedroom, there's one in the hall, there's one in the summer house, and so on. And the only thing that makes them different is the location, but the data doesn't contain the location. The location comes from the channel, from the topic. So we need to add that to this JSON object when we're actually going to store it in our database. So that was my first attempt there, and that worked fine. However, in Influx, if you want to index a particular field, like on a database, you want to sort by something, and they call them tags in Influx. You need to tag that differently. You need to split out the 2 bits of data into 2 parts, and this is what this array function does, and we'll have a look at that in a minute. And then that simply passes it on to Influx, and then that will store that as a single reading within the database. So within there, here we go, this is what I was saying about there's 2 variables. So the existing payload that's got the sensor readings in there, maybe it's got the pressure, humidity, and the temperature. And then what I'm then doing is saying I've got a second array and I just want to set the location to Summerhouse. And then the payload then becomes equal to the first one and the second one. But because they're in an array, Influx know how to handle that, and it always expects the second block to be tags. So that's how we can then filter and add that to our database. Bit fiddly, but it works. I spent all Saturday trying to figure that out. So Influx is a time series database. If you've not used this before, it's free to download, open source. They do have enterprise versions of this, but they're very generous at letting people use this for personal projects and so on. And yeah, it's a time series database. So these databases are specifically designed for any data that's in time records. So things like logs from a web server, sensor data like ours, anything that comes in as events in time that you want to record, and then later on you want to use that time element of it to slice and dice the data. So Influx is designed perfectly for that. What I didn't realize, it's been written in Go, the language. So I've never actually written anything in Go. That's something I want to look at, but the entire database has been written in Go, and it has retrieval of time series data for things like monitoring, application metrics, Internet of Things sensor data, which is what we're doing, and real-time analytics. And it has also support for processing data with graphite, which I have no idea what graphite is. So anyway, Grafana, I know all about that now. So Grafana is a multi-platform open source analytics and interactive visualization web application, which is a bit of a mouthful. It does really nice dashboards. So it provides charts, graphs, alerts, which is quite cool. That's something I'm going to look at. So if something goes above a particular threshold, you can get it to message you in some way and alert you. And it's got a really extensive plugin system as well, so we can build it out and add things to it. An end user can create really complex monitoring dashboards with interactive queries and so on. Really, really quite cool. And Grafana is composed of a front end and a back end, written in TypeScript and also Go once again. So Go is clearly a bit of a go-to language. So let's move on swiftly from that bad joke. So I've included all the install scripts for the MQTT broker, which is called Mosquito, for Node-RED, and also for Portainer, which manages all the different nodes, and Grafana as well, and InfluxDB. So they're all in the Clustered Pi repository. So if you want to grab a copy of that, here's another web link to look at. This is github.com/KevinMcAleer/clusteredpi. And that's where I keep all those bits and bobs. So yeah, if you want to support the show, if you want to help out, you can go over to buymeacoffee.com/KevinMcAleer and buy me a coffee, and that can help pay for all the equipment that I use, all the streaming software that I have to pay a monthly subscription for, and all the music, royalty-free music and so on. Or you can also just go to YouTube and click that little join button. And if you want to join me on the live stream, I do go live every single Sunday at 7 p.m. GMT, so come and join me as well. We've got quite a few people on the stream today, so I'm quite pleased about that. And we've also set up recently a Discord server. So you want to go and join the Discord server, we have another link for that as well. So Alex has just posted a link to that in the live chat, but action.smilesfan.com/join-discord. I'll try and make a shorter one for next time, but that's what the link is for now. Okay, demo time. Let's get over to the demo and let's have a look at what this is all about. So let me just get my little notes up here. So the first thing we were going to look at was the code. What I will do is I will load up Visual Studio and I'll show you what we can see in there. So just while that loads up, I'll share my screen once that's all ready. This takes a couple of seconds. Hopefully it doesn't overload my machine while it's doing that. Right, I should have loaded this up before, but it takes so long to load. Come on. Get over here and you can see that's just popping up now. So I've got a little extension in Visual Studio that allows me to connect directly to that Raspberry Pi. So I think it's just called SSH Connect, something like that. It's like remote execution. So you can connect to the Raspberry Pi and then execute code, but have all the niceness of running it through whatever software like a Mac or Windows machine. So just waiting for that to connect to the Weatherhat. You can see there it says opening remote, and it's just going to ask me for a password in a second. So yeah, setting up the SSH host, I can see it says there, just underneath my face there. There we go. And in a second it will ask me for my password. Okay, that's nearly done now. There we go. So I'm just going to change the screen for a second while I do that, just in case. Did that go through? Yeah, it's getting a little bit laggy. I think I've maxed my machine out here. So if I'm lagging, it's because I'm running too many things. Just bear with me. There we go. Right, it's connected now. So this is actually running on the Raspberry Pi that's doing all the processing for our weather station. So what I wanted to show you is that code kind of in action. I have just done another video, I've not uploaded it yet, which is going through all the examples for the Raspberry Pi, for the Pimoroni Weatherhat. So I'll go through all the example code and show all the different screens being updated and so on. It's really good. So you'll watch out for that, but actually not on my channel, that'll be on the Pimoroni channel. So that's coming very shortly. I've just recorded it. I just didn't want to upload it before this show because I would have had no bandwidth whatsoever. Okay, so this is actually now running on the Raspberry Pi. So if I open up a terminal, we'll actually see that that is running on the Raspberry Pi. There we go. So WeatherPi. And if I think it's actually running the code as we speak, so I can't get it to run twice because that will crash it. But this is the code that we just looked at a couple of seconds ago. You can see it's very simple. What I do like about the using Visual Studio is these strings become a lot easier to read because the colours, you can see what you're doing there. One of the things I had to find out how to do was how to escape out one of these little brackets when you're doing F-strings, because that's what F-string uses to recognize a variable. So like date timestamp.now, which gets the timestamp for now. I had to escape that with a double squiggly bracket, whatever they're actually called. So that's the code. I've simply got that running on the Raspberry Pi. So let me show you how I've done that. So I think it was... let me have a look. There's about 4 different ways of having a script start up when you boot your Raspberry Pi. So what I've done in etc.profile, let's just have a look. Sorry, if I just cat that profile and I expand the screen, what you'll see, the very last command there, sudo python, and then this is the path to the code. So home.py, weatherhat to MQTT, and then weatherhat to MQTT.py, and then the little ampersand means just run that in the background. The annoying thing is when you log in, you do see all that sort of code going past the terminal because it's echoing out stuff all the time. I could probably just get rid of the print statements, which is that very last print statement in there. If I just commented that out, it wouldn't have all that junk showing on the screen, but it can be quite useful when you're debugging the code. But that's one way of doing it. And then I've got the Pi to automatically log in, which isn't particularly secure, but it'll work for now. My intention there is to have this running in a Docker node, so I'll be working on that. So I'm just going to, I'll tell you what I'm going to do. I'm going to reboot this Raspberry Pi, because then it'll kick off its code and run in the background, just in case I've done anything funky with it. Right, so I'm just going to close down Visual Studio because we don't need that again. So let's just quit that. And then what I'm going to do now is I'm going to load up Node-RED. So let me just get Node-RED. Now I've got that open on another tab, so we're ready to go here. And what I'll do, I'll just give us a nice blank one. Let me share my screen. So this is Node-RED. This is running again in another Docker instance on the same machine, and actually we can have a look at that machine. So this is a piece of software that's called Portainer, and it means you can look at all the different containers that you've got running on that particular machine. So here's the Portainer which runs this piece of software. The Jekyll app is running the website clustered-pi.com. We have another app there which is just running, I can't remember what that is. We have Grafana and we have Node-RED. So Node-RED is currently running on that port there, 1880. So if I go to 1880 on that particular machine, this is what I get. So what I can do, let's just do a little program. This is what I love about Node-RED. It's so simple. I'm going to plug in a MQTT in. I'm going to just grab the debug, and then let's just connect these two together. So I'm just going to deploy this, and I'm just going to delete any messages that are there. I'm just going to move my face out of the way for a second. And what we can see here is that we just have this MQTT. So what we need to do is define the topic. So I'm just going to say, give me everything. Hash is like, give you every single message that's coming through. And we can see there, we've got a message there from home temp bedroom. We've got one from home temp hall. And then we've got one from weather. And look at all that. All that is our weather data that's coming from that script that we wrote in Python and that we ran a couple of minutes ago. So, and we can see that every time it receives a new message, this little green debug node will just sort of flash and light up. So what we need to do is we want to be able to push this to our Influx database. So all we need to do is just install the Influx node. So if I go over to here and I go to, I think it's configure node. No, it's not configure nodes. It is, let me just move my face out the way, manage palette. And I've got the Node-RED contrib InfluxDB node installed. And you can just find that by clicking on the install and then just looking for Influx. And you'll find it just there. So that one's installed. And that will give you a couple of extra nodes down here that you can pull in. So if I just scroll to the bottom, we have Influx in, Influx out. And we're just going to pull the Influx out one, connect those two together. But that's going to send all of those different things to the Influx without really putting any logic around that. There we go. So what we need to do is split out the location of that data. So each of those, like the hall, the loft, the bedroom, they all need to be running in a separate node. And what we can do there is we can actually just say, instead of give me everything, just give me, for example, weather. So that will just get all the data that's coming from, let me just confirm that and delete any records there, and we'll see that it just comes through as blocks of data. There we go. So you can see there, date, time. Now if we want that to look prettier, like a proper object, what we can do, we can use one of these JSON parsers. So if we stick that in between there, and then I deploy that. I'm just going to disconnect that for a minute because it's complaining about the setup there. I'm just going to deploy that. And instead of it just being like a red block of text, we're actually going to get an object now. We can see all the different parts that make up this thing. We can see that we've got a timestamp, we have a temperature, we've got a pressure, humidity, and so on. So that means that that's a lot more easy for us to understand. And then if we want to inject another record of some kind, we can just use something like one of these functions. We can just put that in there. In fact, I think we can just use the switch or change. Let's use the change one. So we can just drag that noodle into there. I love the way that these things connect. And then we can double click on that, and then we can just add an extra piece of information to this. So we can say, let's set message payload.location, and let's make that equal, I don't know, Fred for now, just so we can see that it sticks out. So if I deploy that, and we now look at the data that's coming through, there'll be an extra, oh, it's not liking the way that I've done that, payload.location. Oh, it's because I've not set that to anything. Let's get rid of that one. Let's deploy that. And let's just kill that. If it comes up with an error message, we can just have a look at the other node that's working correctly. There we go. Right, so if I look at this, and I move my face out the way again for a second, we can now see that the location is now Fred. So very simple to add extra bits of data to this. And then when we send that to our Influx database, it will then store that with that location in there as well. So all I'd need to do to configure Influx is just double click on it and then just tell it what the server is. And the server, when you actually install the Docker node, it will tell you what the extension for that is, like the port number. I think it's 3000. So I've just got that running on 1.10. Oh, sorry, it's 8086, which is quite comical. That's the processor, isn't it? The original Intel processor. So there we go. That's Influx. So I'm just going to delete all these bits and bobs here, and I'm going to show you on flow 1. Let me just deploy that. If If I go to flow 1, we can see what's actually happening. So I've got 4 different MQTT topics. This Weatherhat topic here is doing what we've just done. We've made it JSON, we've added location. This array thing is just so that we can add in some tags, and I'll show you that in Grafana very, very shortly, and then we send that data to Influx. So we're nearly there now. So if we go over to Grafana now, excuse me, Grafana, if I go back to here, let's just discard that. And this is what Grafana looks like when you've installed it. So again, very easy to install using Docker. You can just sort of put together a container that's running Grafana. Pretty much works out the box. It does have user accounts. I've already signed in as an admin, so I can create new dashboards. But if I do create, this is what we do to create a new dashboard. So I'm going to create a new panel. I've already connected up the data source, which is the Influx data source, and that was simply just a matter of going to new data sources, which I think is in the settings somewhere, data sources, and yeah, let's just discard that for a second. I'll just show you how you do this. You just say add data source, you pick what kind of data source it is. Ours is an InfluxDB. You type in the address, so there's 8086, so whatever node it's running on, just type the IP address 8086, and then down at the bottom you can then just do save and test. So I've already done that, I've already got that set up. Let's go back to our dashboard and create our new dashboard. So I'm going to add a panel. The data source is InfluxDB, and then down here this is a query, and you can just type all this in, or you can just click things to select. So I'm going to click on here, and I want to get stuff from the weather. Remember when we set up our Node-RED thing, that's going to send things to weather. And I'm going to pick the field, so let's go for, I don't know, temperature. And there we go, immediately it started plotting some data on there. And we can also do things like the where clause. So because I've included that tag that's called location, I can then select which particular sensor I want to use. If I use the loft one, that's quite cool because it's above the insulation of the house, so it's very, very cool up there. And that means that that's now got a panel. So if I just click that, we can do things like resize that. We can do a bit more configuration of that as well, because currently it's got some numbers down there and we don't even know, and it just says panel title. So we can give this, let's call this loft temperature. This is using time series. We could go for something else if we wanted, like a gauge. And then you can just configure what you want the sort of minimum and maximum things to be. So if we choose the unit to be temperature, I think it's Celsius. If I just move my face out the way there, you can see we can... Celsius is with an S, isn't it? There we go. So it now knows it's 11.2 degrees C. And then you can say what the minimum temperature might be. So say maybe -5, and the maximum might be, I don't know, 30, something like that. And that'll calibrate, you know, where you are on that particular range. So if I apply that, and you can also add thresholds as well. So it'll give different colors for thresholds. Let's have a quick look at that. If I scroll down again and look for the thresholds bit, I think we have to switch that on. There we go. So currently, so I'm sure we have to say enable the thresholds. I might just move my face out of the way again. And what we can do on here is we can set various different thresholds. So let's add a threshold. That's not going to be, let's make that 30, which is the maximum, or maybe anything that's over 25 is red, anything that's over 20 is orange, and so on. So you can now see we get these little gauges like that. Let's have a look what else we can do. I'm sure there's a thing that actually adds the show threshold labels. There we go. So it's now like a little thermostat kind of control. So let's apply that. So that's our first one. If we want to be able to do things like show the wind speed, let's go and add a new panel for that as well. So let's just click on that, add panel, go to our panel, let's select the measurement weather. The field is, oops, the field is going to be wind speed. There we go. There's our wind speed. You can see here where I've switched things off while I was recording data, because we're recording the show, because there's like missing pieces of data in there. And that spike there is probably incorrect. I don't think he went up to 80 miles an hour there. So what we can probably do is just filter those out in a minute. So we can do that by setting some more things down here. So if I go to the minimum and maximum, so again this is wind speed, so it's meters per second. So if we do that, velocity meters per second, it's now got that correct over there. The minimum is 0, the maximum, let's say, I'm going to go for 10 meters per second. And then we'll name the panel at the top as well, wind speed. And I think on here as well, you can actually name this alias. So instead of saying the mean weather, because it can take several readings and average them out, so we can just call this wind speed, like so, and that'll just update that over there when we apply it. So we've now got the loft temperature and the weather wind speed, and we can move these around as we wish. We can have a few of these. Now I've actually got more than one temperature thing coming in, so I could add individual ones, or I can actually just add another query, like a query B. So we can add in there another weather one where the location equals bedroom, and it's grabbing that from the data from the tag. So I've not had to define bedroom, it's just looked at those and knows what that means. Let's get the temperature. There we go, we've got two of them now. We can add a third one in, which is like the hall. So you get quite quick at this after a while, where location is hall. And then let's make that temperature. And we can also just set those aliases as well. So make that one bedroom. Make that one hall. And there's one missing, which is that first one, which is loft. Okay, let's just apply that. And we've got a little thing there, we can make that a bit larger. Maybe move that over there. Okay, so we can start building up our dashboard and add in more things to this. So we could add in, let's add another panel. Let's get the pressure this time. So let's go for weather, where the field is pressure. And this is in, is it hectopascals? What's the name of the unit there? If we go down to units, and if I just type in pressure, so we can either do millibars or hectopascals, that's right. So you can look at it like that. These are kind of interchangeable between, we'll do hectopascals, like so. You can just see it like that, 1,000 hectopascals, or you can have millibars if you're in the UK. There we go. Doesn't change the scale of anything, that's fine. And we can just name that as well as pressure. And the actual panel can be called pressure as well. Apply that. So we're getting our data, we're building up our dashboard, and we can do a lot more with that. Grafana is so flexible. There is so much you can do with this. So I'm going to show you the. Let me just save that dashboard. We'll call this one live. Oops, can't type dashboard. And if I now go to my other dashboard, which is the one I prepared earlier, this one has got a few more things on it. So we've got the relative humidity there. Again, that's been formatted correctly for the humidity scale. We have the pressure. We have the wind speed in the last minute. And what we can do, this little button here gives us the ability to look at this data over, say, the past 7 days. So you can see there when I started recording the data, you can go back to the last 6 hours. You can see that there's blocks of data missing there where I was recording the show when I was messing about with the sensor. We can have a look at the past hour like so. And we can see things like the dew point changing nicely there. We can see I've got a different type of temperature thing here where I've done it as a graph. And if I just move my face out of the way, you can see here, if I just move this in a bit. Let me just move that there we go. You can see here, if I actually click on these or hover, I can see which one I'm looking at. So that's the hall, that is the summer house, and down there's the loft. Now, it isn't actually 27 degrees in the summer house. The temperature sensor is actually underneath the air conditioning unit, so it's artificially making that look a lot hotter than it actually is. The hall one is also sat next to a mains plug that's really hot, so it isn't actually 25 degrees in there. This one that says bedroom is the one that's actually, it's a different module. It's an ESP8266 module, very similar to this WeatherBot that I created here. I'll just show you this. This is a sensor I created. I did a video about this. You can probably, if you search for WeatherBot, and what WeatherBot does, if I just pull the power out and put it back in, like so, there's just an ESP8266 on the back, and this just pushes the data. So you just, there we go, just resetting his settings. And on the back there's an ESP8266 or a Node MCU as they sometimes called. And that just connects to this little temperature sensor on here. And this sends data up to that same MQTT broker. So if that script's working correctly, we could see that data on there as well, but I don't think it's working quite right, that. So what I'm saying there is I built several weather sensors using that exact same technique. So an ESP8266 with a DHT22, just plugged that into some pins, created a small Python script. If you look for WeatherBot, I think it's github.com/KevMcAleer/weatherbot. The code for that is there. I think it's WeatherBot. There is a video, you can search for that anyway if you want to. So yes, that is publishing data to the MQTT, and then that is what you can then see on this little temperature gauge over here. Now the light levels are the light levels that are coming from that Weatherhat. So that's the light levels in this room rather than light levels outside. But we do have some Philips Hue light motion sensors. As well as having a motion sensor, they also have a humidity, a pressure, and a light level sensor as well. So you can get that to publish to your local MQTT broker and then bring that in using Node-RED and Influx into Grafana. So you can see here I've got all the little gauges set up. So that's just one with all the four things split out. Got one for humidity, one for temperature. I think that label's wrong on that one. And one of the things I need to update on here, this panel here is the direction of the wind direction. So currently that's just showing you the wind direction sort of blowing around, but it's showing you the number of degrees, and I need to calibrate that. So I'm quite lucky that I live directly, so north is that direction, south is that direction, so east is that way, and then behind me is west, and it's very, very sort of straight on to that. So it should be very easy to calibrate the weather sensor wind vane direction based upon that. So rather than just having degrees, we could actually say north, northeast, northwest, and so on, but I've not figured out how to do that yet. But that'll be a very simple thing to sort of probably do in either Node-RED. We can take that angle and we can just say if that angle is this, then change the payload to be west and so on, and then we can bring that in there. But I want a little weather vane. I'm sure there will be one. So that's that. What else have we got here? Yeah, these spikes are probably when I unplugged and plugged in the connectors, and that's why it's spiked out there, because the wind speed wasn't like whatever it thinks that was up there. It thinks it was like 5. Yeah, it definitely wasn't that. So this is a work in progress, but what I really like about Grafana is we can access this anywhere on our network when we're at home. So I've got a little app on my mobile phone. If I click on that, I can then go to my weather station, and I've got that exact same dashboard, but as a mobile view. So it's the exact same data. We have a Amazon Echo Show 15, one of the great big screens in our kitchen. There's like a kitchen TV, and we've also got that web link on there as well. So you can open that up and have that full screen and just see things. But you can actually see, if I go back to that dashboard, I can show you some of the data when various different storms were happening. So let me just go back, I don't know, 24 hours, maybe a bit more than that. Let's go for the past 2 days. Let's go for the past 7 days. So where this was going up, 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 and then down, that's where we had that storm Eunice happen. And then there was another storm the next day, which went even further down, where it snowed. There was like a flash, flash snowstorm that occurred, and that's where our cars got had to be abandoned. We live on a hill, and when the hill goes down, that's where all the cars get stuck because they can't make it up the hill when there's any kind of snow. So it's always good fun to go and sit in the pub next to that and see all the cars struggling. Harsh. So that's what I've got for you today for the show about weather stations and how to use the sensor data and put it into things like Grafana. So this is the point of the show where if you're watching this on replay, I'll say goodbye. And if you're watching on live, then we'll carry on the conversation and we can have a look at some of the messages in the chat. So I'm just going to scroll back a bit.